In this video, we're going to talk about design patterns. A design pattern is a proven solution to a common problem in software engineering. To use a real-life example, early man has always had the need to stay warm and find shelter from wild animals. One solution was to use animal skins to make a teepee. This protected from wind, but it wasn't very sturdy. Also, a bear could walk through that entrance any time and eat your children. So over time, people have developed improvements on the teepee until eventually you end up with the modern house. It's sturdy, well insulated, well lit thanks to windows, and it's got running water and a fast internet connection. In the same way that if you wanted to build a house today, you wouldn't have to start with the teepee and rediscover for yourself the better ways of doing things, a design pattern in software engineering exists as a template to solve a common problem. In this video, we'll introduce you to the Model View Controller Design Pattern, or MVC. The Model View Controller pattern is a way for programmers to structure their code and stay organized. Remember how we discussed how all the files in an Android app are organized in a certain structure? Images go into a drawable folder, launcher icons go into a bitmap folder, the design of the screen goes into the layout folder, and separate from that, you have the Java code and the Android manifest file. The reason for splitting up all the different parts of an app is to manage the overall complexity and to stay organized. Each file has a specific job and is separate from the others. According to the same logic, the Java code can and should be split into different files according to what the different code snippets do. It would be an absolute nightmare to have thousands of lines of code in a complex app all living in the same main-activity.java file. That way you end up with spaghetti code that would be horrible to work with. In other words, developers all face the same problem. As they write more and more code to make programs do more and more things, their project eventually becomes unmanageable. And by unmanageable, I mean that every change to the code breaks the program in an unexpected way. In other words, the complexity gets out of hand and the developer can no longer understand the software and the relationships within the code. And this is where a design pattern comes in. Design patterns help developers structure their code, solve common problems, and keep complexity manageable. The design pattern that we'll talk about and use is called the MVC, or Model View Controller. This way of organizing code was first introduced by a Norwegian chap called Trygve Reinskaug while visiting Xerox PARC in the 1970s. MVC has since become widely used as a way of building web applications with Ruby on Rails, but also as a way of building apps for Android and iOS, as well as in many other use cases. So let's talk about the components that make up the MVC. The M stands for model. This is the bit that manages the data. The model is not the data itself, but it's the code that's responsible for creating new entries into your database, deleting things from your database, or reading from the database. The model structures and packages the data and provides it when it receives a query. The V stands for view. This is essentially what you see on screen. And finally, C stands for controller. This is the bit of code that sits in the middle. The controller handles the communication between the model and the view. Say you have a contacts app and are looking for Jennifer's phone number. When you type in Jennifer into a search box on the screen, the search box, which is part of the view, will pass that information onto the controller. The controller will now do some processing. It might check if you've submitted a valid query or if the results for Jennifer aren't already being displayed on screen and don't have to be fetched for a second time. After the controller has checked that your request is appropriate, it will send a message to the model requesting the data for Jennifer. The model then searches the database for all the entries containing Jennifer and provides these to the controller. Note, the model is not the data itself. The model is not Jennifer's contact details. The model is like the storeroom manager that looks up the information, packages it in a way that the controller can understand, and then provides it to the controller. The controller then prepares that data for display on the view. For example, it may have received 10 Jennifers from the model, but it serves the view only the 5 that the view can display on the screen at the same time. Now, since all this is quite abstract, let's use a real-life analogy to illustrate the MVC design pattern. I'd like to invite you to our restaurant and show you how MVC works in this context. The data is the raw ingredients for the dishes that the restaurant serves. The model is the kitchen that uses the ingredients to prepare the dishes. Those dishes get passed over to the waiter, our controller, and the waiter can take orders and serve orders to the view, which is what you see on your table. Here's how our MVC restaurant works. You'd sit at your table and make a request for pancakes to the waiter, our controller. The waiter takes your request and passes it on to the kitchen, the model. On the other hand, this wouldn't happen if you told our waiter that you'd like to order a blue dragon instead of pancakes. In that case, the waiter will kindly tell you that your request is invalid and to try again. Having received the request for pancakes from the controller, the kitchen, our model, fetches the eggs, milk, and the other ingredients, the data, from the larder. From the raw ingredients, the kitchen prepares the pancakes. This dish is then presented back to the controller. Finally, the waiter brings those pancakes to your table, the view. If we now look back at our Quizlet app, we very clearly have a view, which is our activity_main layout XML. And we also have the main_activity.java file, which is our controller. The true/false class, on the other hand, is our model. It provides a structure for a single true or false question, which contains the question text as well as the correct answer. So what are the advantages of using the MVC pattern? First of all, it provides a structure. This reduces complexity and makes it very clear what bits of code go where. Second of all, the MVC pattern is a very common one. This means that other developers on your team will recognize it. And that might include your future self that can make sense of the code as well. Thirdly, a design pattern like MVC allows for code reuse. Notice how the model and the view never communicate with each other directly? As a customer in the restaurant, you can't just run up to the kitchen and delegate the chefs around to get what you want, because it would result in absolute chaos. This means that in an app using MVC, you can do certain things quite easily, like change the data. For example, if you wanted to change your Quizlet app to French, you can easily change all the English questions to French questions without having to touch any of the other parts of the code in the app. And finally, by having this modular structure, MVC allows for multitasking. By splitting up the code by functionality, it allows developers to work on one part of the code without impacting other parts of the app simultaneously. For example, one developer can design the front end, the view, while another developer works on the back end, the model, without them stepping on each other's toes or getting in each other's way. As you get more experienced and are keen to find out more about different design patterns and what problems can be solved by using them, I would recommend checking out the following resources. The gold standard on the book front was written by a couple of guys called the Gang of Four. It has the title Design Patterns, Elements of Reusable Object-Oriented Software. That said, other publishers such as HeadFirst also provide good introductions to this topic. In the next video, we'll create an array that will serve as our question bank and retrieve individual quiz questions to display on screen. I'll see you there.